Okay, so let's get into second part of this lesson. I will begin with the Oracle Clusterware networking, and then I will get into the major part of the second section of this lesson, which is grid plug and play topic. Oracle Clusterware networking. To be able to install Oracle Clusterware successfully, you must have at least two network adapters. First, private network adapter. Second, public network adapter. And also, each public network adapter must support TCP/IP. And also, the interconnect adapter must support UDP or RDS for database communication. And for clusterware communication, the clusterware uses Grid Inter-Process Communication Protocol. I'm going to actually give you the whiteboard node to give you a little more information. So I made one simple example here. And here we have in left-hand side, this is in server 1, and right-hand side, that's my the second database server. The minimum required network adapters are 2 in each server. One for public, one for private. Public must support TCP/IP. Private must support RDS or UDP. In this example, to make it more realistic, I installed 4 network interfaces in each server. So I can just name it ETH0, or I can do ETH0, ETH1, and ETH2, and ETH3. In this example, I made an ETH0 as a public network, so it is connected to switch 1 and connected to switch 1. So when user connect to each server, and by using this in a network, user can connect to host 01 or server 1. And also, I made an ETH2 and ETH3 as a private network. And these 2 private networks, these are all configured under the different network. So we have ETH1, and that is one network. And also by using another network, we configure the second private network as well, network interface as well. And later on, you will see concept of HAIP. Okay. In 12c, Oracle Clusterware uses virtual network interface and virtual IP address for the private network. So even though we configure the 2 network interfaces for private under the different networks, however, behind the scene, the virtual network will be created, and these virtual networks are configured under the same subnet. Because of that, at the clusterware level, we can easily implement NIC bonding by using redundant interconnect usage feature. And also, in order to make your public network highly available, you can also group ETH1, ETH2, ETH0, and ETH1 together, maybe active-active, maybe active-passive. By doing so, if there is any problem with the network interfaces, we can use another network interface to connect to the same server. So we will need public and private network interfaces. Okay, minimum is 1 each. However, practically, you may want to configure more than 1 network interfaces for public and private. So let's come back here. Okay, so once you install the Oracle Clusterware, and you will see Oracle, init.oracle high availability service daemon startup script. Okay, and this script will start HA process, and also this script will start all Oracle Clusterware dependent processes. So suppose that you installed the Oracle Clusterware already and you reboot it. When you reboot, the system process, init process will call init.oracle high availability service daemon, and this script will start all dependent Oracle Clusterware processes. That's at the startup time. Now what about this? Somehow my Clusterware processes aborted, especially important process like an HA process went down. Then all dependent processes will be down. Now, in order to provide high availability in Oracle Linux and Oracle Linux 7 and 6 and 7, we use the different files. Now look at this. We have this section here. Respawn this script automatically. So if we have a problem with the main startup script, then it's possible to restart the HA process and also all dependent processes. And also in the Linux 7, we use a Clusterware that is controlled by system daemon process to manage start and stop services. Now, since this class is not Clusterware training, I don't get into Clusterware processes in depth, but I will give you a little bit high-level information. So let's get into HA process and also the other Oracle Clusterware files. Okay, so I'm looking at Clusterware processes. When you start Oracle Clusterware, so I'm going to run this command. You can run different command. So if this is a startup command, as a root user, I will run crsctl and start crs command. So when I start this command, what it does is it will start. It will actually start HA process. I just highlighted the important keyword HA. Oracle High Availability Service Daemon process comes up, and then it will start all Clusterware stack processes. The first of all agent processes will be started first. When you look at here, we have a CSS agent and CSS monitor, ORA root agent, ORA agent, and app agent and script agent. And CSS agent, it is to start CSS daemon. It is responsible to keep node membership by using voting disk file. And CSS monitor, it continuously monitors status of a CSS daemon. And ORA root agent is also responsible to start all root-owned resources. And one of a major daemon process that is started by ORA root agent is CRS daemon. And CRS daemon start another two agents, especially this one, ORA agent, and it is responsible to start database and ASM instance, and also non-root-owned resources. And when you register third-party applications, then these agents are responsible to manage third-party applications, and especially script agent. And app agent is for backward compatibility. Okay, so this is the time when you start Oracle Clusterware. And if you have a problem with HA process, then everything will be down. Okay, but if this is the case, let's come back here. If this is the case, in Linux 6 we use Oracle-HA service daemon configuration file. In the file, we have a respawn keyword. So it is responsible to restart. Not only HA process, but also dependent processes. And also, in the Linux 7, we use a different way to start. Okay. I'm going to clean up. Now let's get into one architecture. Create a plug and play architecture. Wow, look at this. There are so many action text and so many diagrams here. And when you're looking at this diagram, it's very hard to understand. But basic idea is this. Create plug and play it simplifies your node addition to the cluster and node removal from the existing cluster. Okay? Think about that. You as administrator. In order to add a new server, what do you need? You will have to configure network interfaces as a public, as a private. You will have to configure underlying storage, and especially to access to share the storage. And there are many things what we have to do, working with the storage admin, system admin, network admin. Now, create a plug and play, it simplifies many of the steps automatically. For example, configuring network interfaces, that's automatically done by create a plug and play. Okay? And also, when you remove a server from the cluster, then cleaning up the network information is also done by create a plug and play architecture. And this is a feature. What I'm going to do here, I will actually touch each component that we will have to discuss. And the next few slides, I'm going to read. And then I will use a class node to give you a little more detailed information. Okay? So let's get into here. And this example is, this is a node 1, node 2, node 3, node 4, let's say node 5. An example is, assuming that this is a 5-node cluster. And since it is a 5-node cluster, okay, you can create up to 5-node rack database, or you can create many small number of smaller rack databases. And also, we have a local listener. What is the purpose of a local listener? The local listener, it is responsible to spawn a server process and then connects to Oracle database instance, and then authenticate user, and then support actual connection. But before that, we also using a scan listener. Scan listener, it is responsible to provide load balancing information. When request comes, and scan listener will check which instance is least loaded for a service. Now, suppose that if first the scan listener connected, and then according to this scan listener, the 5th instance is considered as the least loaded instance. Then your client will connect to instance 5 by going through local listener 5. Okay? So when client requests connection, and DNS may connect to GNS and asking node name resolution. And then connect to scan listener and local listener. There are many things going on. And I will address this area in a minute. And the other one is, with the create plug and play, you configure DHCP to obtain IP addresses automatically. So when you add a new server, we will have to assign node VIP and also other addresses. So DHCP, it works with GNS, create a naming service, to assign IP address. And also we can clean up as well. So there are many other components available. I will address more detail in next few slides. Okay, so how grid plug and play works. When you start up Clusterware, number one, IP addresses are negotiated for public interfaces using DHCP. So obtain IP addresses from DHCP and to assign it to rebooted the server, or in a server where in a cluster where it restarted. And then create a plug and play agent is started, and this agent will get profile information to understand and to configure underlying storage and also to start up all additional services. So when you restart Clusterware, IP address assignment and configuring underlying storage, that's automatic. And it's also same when you add a new server, when you remove a server. So you can simplify cluster management. So this create a plug and play feature is very useful if you manage a dynamic cluster. If you manage a static cluster, meaning that you have the same number of a cluster and you don't change it, the size of a cluster over the time, then that is a static, my terminology. Okay? Flexible means today you have a 3-node cluster and you should be able to scale up, scale down dynamically, maybe cloud environment. Okay? So in the more dynamic, in the dynamic environment, you may want to implement create a plug and play feature. And in the create a plug and play environment, create a naming service was the mandatory component. Okay, so I said it was mandatory component, but it's not mandatory anymore. So when I prepared the 12.2 Clusterware, I was a little confused because of this small change, but I will give you differences. It was actually the mandatory component. In order to connect to create a naming service, in the DNS, you had to specify location. In this case, 192.0.2.155. So when client requests a connection, DNS identify address of a GNS and locate GNS, and GNS can resolve host name. So subdomain and host name resolution was delegated to GNS. And GNS is a cluster resource. It is running out of one of the servers in the clustered environment. Okay? And what GNS does, it works with a multicast DNS to resolve host name. So GNS, it can resolve host name by working with a multicast DNS. And also GNS, it can obtain IP addresses by working with DHCP. So we use actually GNS for name resolution and also to simplify network management in case of a node addition and node removal every time when you restart Clusterware. Okay? And we also have a single client access name. Single client access name, a name that client will use to connect to database instance. Okay? So before you install Oracle Clusterware, you will have to define single client access name. So which name do you want to use? It's got to be something meaningful. Okay? And then you work with network admin team to associate this single client access name with the 3 IP addresses. In this example, in the DNS or GNS, we already identified the 3 IP addresses. So with a single scan, and there are 3 IP addresses associated. So we have this IP address, 192.0.2.243, 244, and 245. Okay? And these are all IP addresses. And I will cover more in a minute. So at this point, I'm going to show you my handout. Okay, so I'm going to show you this. When you install Oracle Clusterware in 12.2, you have 3 possible options in terms of a network configuration, in terms of a GNS configuration. So I'm going to give you 3 possible configurations. And to understand this concept, you will have to understand concept of a GNS, concept of a scan, concept of a scan listener, there are many concepts you have to understand. I will touch one by one. And the first example here is standalone cluster deployment option 1. I want to configure my cluster without GNS. Wait a minute. We have a question. In 12.1, when we deploy the cluster with a flex cluster option or flex cluster the mode, there was a strong requirement. You must use GNS. That's a requirement. But when I reviewed the 12.2, we could also install clusterware in flex mode without GNS. I was very surprised because requirement was different. So finally, I understood better, and then this is what I understood. Now in this example, in the right-hand side, we have a 3-node cluster. So we have host 01, host 02, and host 03. And we have ORCL1, ORCL2, ORCL3, and 3-node rack database running out of a 3-node cluster. And also, in this example, I started the app service across 3 servers. And also, we have a local listener, another local listener, another local listener. Local listener is responsible to make connection. And also, we have a scan listener that gives you load balancing information. Okay? Now, where is the location of a scan listener? Location of a scan listener is scan VIP, scan virtual IP address. So in order to locate scan listener in the specific scan VIP, before installing Oracle Clusterware, you have to work with the network administrator or DNS administrator to specify network IP address for the scan listeners. So in this example, so I will have to add all this information. Okay, so I have a 3 host, so I need a node the host name for public and each IP address. And we have 1, 2, 3 IP addresses. And also we have a node VIP IP addresses and also private IP addresses. Now, here we have one thing, scan. My scan is associated with 1, 2, 3 IP addresses. Okay? So what is the actual what is the purpose? What is the scan IP? This scan IP is the location of scan listener, and also 202 is here, and also 203 is here. So it is a location where scan listener is running, and since it is the scan VIP, it can be running anywhere in the cluster. Okay, the rule is these IP addresses should be running in the different servers. So that way we can spread the scan listener across multiple servers. Now, based on this, suppose that I configured the client in this way. I updated the TNS names, and I provided a single client access name, which is scan. And then I provided the TCP IP and port number and service. I want to connect to one of the instances where app service is running, and they give you better performance. So when request comes and DNS, it will check whether GNS is configured or not. In my example here is we don't use GNS. That's why all IP addresses defined in the DNS. Okay? So since the client provided scan CL01-scan, and that must be translated. So in this example, let me choose actually one of the IP addresses. I'm going to choose this IP address because it is a round robin. So I can choose a first or second, third, doesn't matter. I pick one of the IP addresses. So my scan is converted to IP address 192.0.2.202 in this example. So where's your location? Here. This is the location. So my connection request is forwarded to here, and the scan listener, it will return list loaded instance information. For example, in this example, third instance is considered as a list loaded instance. Then this information returned back to client, and the client will connect to local listener where third instance is running. And then this session will be authenticated, this connection is authenticated, and finally we can make connection. Okay? So without GNS, all required IP address must be available in the DNS. Okay? So that's one possible option. And even with the Flex cluster in 12.2, you can use this option. But there is one rule, and there is one thing what you cannot do. Since you remove the GNS component, you are not able to use the leaf node. So you cannot make your application tier server highly available, because your application tier server uses GNS, okay, to connect to hub node. So this configuration doesn't allow leaf node. That's one thing what you have to know. Now, second example here, I configure GNS, but GNS doesn't resolve host names and IP addresses. Okay? So it's very similar. In this example, I have all IP addresses. So host name resolution is done by DNS. Wait a minute. We had a discussion. GNS can resolve host name, but we configure GNS. How come GNS cannot resolve host name? Okay, that's based on your requirement and also your preference. I don't want to resolve host name through GNS. Okay, but I want to use GNS to support internal feature. For example, I want to use ACFS, I want to use HANFS, I want to use leaf node in my cluster in the flex mode. Then you need a GNS, even though you don't want to resolve host name, because I want to configure DNS to resolve host name. So in order to leverage internal feature, I stick with the GNS, but I will provide all required IP addresses directly in the DNS to resolve host name at the DNS level. So I wrote down here with the GNS, but without subdomain delegation. So in this example, when request comes, we use scan to locate IP address, and also to locate scan listener that is available in each IP address. Okay, and also this GNS, okay, it is running out of 192.0.2.1 according to DNS, and this will be used by your leaf node and also internal flex cluster features, but not for the name resolution. So that's another example. But in addition to internal features, I will also simplify network management as well with the GNS. If that is the case, you use the third option. Third option is, I'm going to get rid of all these IP addresses. I don't need private. I don't need the scan. Just get rid of all these IP addresses. I want to use GNS. I want to let it configure. So that's what I want to do. Okay? So in this case, in the DNS, you need only public network and also GNS VIP. So when request comes, we connect to GNS, and GNS resolve my scan single client access name by converting to IP address. So eventually we can locate, scan listener. And also, when you add a new server, when you remove a server, then we use the DHCP or IP version 6 auto configuration to obtain IP addresses automatically. So this will, we can take advantage of, we can take full the benefits of a GNS in this example. So you have one of the three possible options. Based on your environment, you choose either first option, which is without GNS option, second option with a GNS, but only internal feature usage, and third option with a GNS and subdomain delegation to take advantage of a GNS feature. So this is actually three possible configurations. So let's come back. So based on this discussion, so this diagram is giving you this information. So we have a database client. It requests a connection by using scan, port number, protocol, service information. DNS, it checks whether GNS is available. If a GNS is available, locate GNS. GNS resolve scan host name. And database client uses IP address where scan listener is running. Scan listener will return list loaded instance information, and database client connects to local listener that is running out of list loaded instance. And finally, we make connection. Okay? So this is the example of GNS usage. In my class note, it was case 3, option 3. And I gave you a little more information. Okay, so this is the second part of lesson 1. I briefly introduced usage of a grid plug and play feature and GNS, the GNS options. And that's for the second part.